You got the same point.
Everything in terms of the one thing I do to get over.
Wat kunt spelen met dat spel? Heel lekker shoot.
Issues I've had ever since you grabbed me.
That question. But the second part of the question says if half the entire thing is that the entire thing is
Yeah, this is half the volume. I don't know how to say that. And that means you have all of it on up.
Hey, you
I don't know how to solve that.
I mean, this is what
I think we've got a bunch of odd ends, and then we'll have pretty much a full picture of the simplest problem. Now, we've been running so far a total condenser, so we've been taking this stuff out, condensing some of it, returning it, taking the product off. We've always regarded the partial condenser as an equilibrium stage. Now, it's in our lab for sure, and it's probably more likely that people will run something called a total condenser. And what they do is they condense everything, split it right here, send some here, send some there. This is the product. The product is now liquid. So while we used to call this YD, we'll now call this XD, and I want to make a remark. Two or three remarks. Number one, it's no longer a equilibrium stage. You're just condensing everything. Now, a stage. And the other thing is that, as you probably learned somewhere along the line, you really can't condense everything without subcooling it. So we will imagine there's an HD up here, HD here, and that this HD is subcooled below H by an amount delta T. Subcooled. You just can't escape stuff that goes over and condenses on a cold wall from cooling further while you're trying to condense the rest of the stuff. So this is usually subcooled. So the first thing we want to do is decide how our V and L are related to the V star and L star we see out here. Both differences are D, so we'll write V minus V star equals L minus L star. Well, I didn't really write it in difference form. These are the same. V minus L is D, and well, what I've done is I've rewritten V minus L is D, and V star minus L star is D. So V minus V star is L minus L star, so we might say something like H V minus V star is HL minus HD L star. These are the saturated liquid enthalpies in the column. This is subcooled. This is also probably saturated vapor, but it doesn't have the same flow. So let us look and see what we can do with this. I guess first I could put L minus L star in here. And that's HL, and that's HD L star. Okay, I could take this H over here. All right, I'll go H minus H times L. That's these. I'll go, what do I have to do here? H, all right, I will write H minus H times L star. But I've taken that over there, so I gotta do something here, and I guess the something I gotta do is put that back, that back in. There's the H, there's the L star. I've taken account of this and that. I've taken account of this and that. I gotta put the L star back in, so minus, I don't like the way this looks. Oh, let me struggle. HL, I like it. HDL star, I like it. HV minus V star is L minus L star, I like it. I like this, I like that, I like this. So what should I do? I guess I don't think I've done anything wrong, but that is certainly an awkward way to do it. So let us not do it so silly. Let us write this as HL. I might as well put minus H. I might as well put H times L minus L star. That would be good. Minus HD minus HL star. Oh, that's much better. I think I got it right too. We know that this came from here. We know that that came from there. This came from here. HL, you can see that there. Minus HDL star, you can see that there. H minus L star plus H times L star cancels out. Hot damn. Lambda L minus L star is equal to, takes care of him and him. Looks like it's H minus HD L star. Good. Lambda L equals lambda plus H minus HD L star. Good. So L star over L star over L is equal to 1 over 1 plus H minus HD is CP delta T divided by lambda. Okay, now I know how L star relates to L. Great. Why does L star relate to L like that? The reason is that,
What's the lambda here?
let me, so L star over L is a number less than 1. So if I'm calculating a reflux ratio based on what I see outside the column, R star equals L star over D. Reflux ratio inside the column, which determines the slope of the operating line, is L over D. So R star over R is also equal to 1 over 1 plus CP delta T over lambda. So if you're out here, sitting out here running and you're saying, oh, the boss wants me to run an L star over D, a reflux ratio that I see on my rotometers out here of a certain amount, you're going to have a different reflux ratio in here. In fact, it'll be a bit higher. Why is this the case? It's because when this stuff comes back cold, so this stuff is cold, when this stuff comes back cold, you got to condense some of that to heat it up to saturation. So some of this condenses. And that makes V star less than V. That makes L star greater, L greater than L star. And the reflux ratio that you're looking at on your instruments outside is not the reflux ratio in the column. So that's the total condenser. So there's not much to that. We've pretty much done calculations like that before. Let's move on to predicting what the outputs are. So here's the deal. I have a column, and I know the feed. So here's what I know. I take a look at this column. It's sitting there before my very eyes. I know F, I know Z, I know HF for sure. That's the feed condition. I know the reflux ratio because I'm controlling it. I know the boil-up rate because I'm controlling it. That is to say, I know QD and QB. And I know the number of stages in, and I know the feed stage location. So my picture is this. Here's the column. I'm looking at it. Here it sits. Number of stages is known. Feed stage is known. Reflux ratio is known. Let's draw it like this. Boil-up rate, V prime is known. Coming down here, got a product coming out here. I'd like to know XB, and B, I'd like to know D and XB. So what's the problem? Can I predict? Can I estimate D, XD, B, XB? And of course the answer is yes. So what's my game here? Consistent with all of our approximations so far, I look at this and I say, let's take a look at this feed plate. And I know that I've got F equals V minus V prime minus L prime. I also know that we calculated one time something like this. L minus L prime equals V minus V prime times something or other. I think it was lambda over CP delta, well, actually that was for the subcooling case. It must have been H minus HF over H minus HF in a general case. I know all that. I'm input F, V prime, and R, so I haven't used R yet. Okay, I'm inputting R. R is equal to, R over R plus 1 is equal to L over V. Now, I get these three equations here. I look at them. I know F, V prime, and R are fixed. How many unknowns are there? Well, there's only three, L, V, and L prime. So I solved these three equations for L, V, and L prime, and I now have all those flows. And once I solve them for L, V, and L prime, I'm in a position to calculate D and V. So, in this simple model, got a number of stages specified, a feed stage specified, a reflux ratio, a boil-up rate, a feed. I pretty much start out knowing the product flows, D and V. So I got this guy, So my problem boils down to, I wonder what XD is and XB is. Okay, let's see what we have. We can go to our diagram and we can put some stuff on here. So somebody, I guess I'm a little careless with this. The pressure's also set, so I have the equilibrium curve. And I'll just draw my 45-degree line here. I'll put Z on here. And here's what I know. First thing I know is that FZ equals XDD plus XBB. So I don't really have two unknowns, I only have one unknown. Because XD would imply XB, or XB would imply XD from this equation here. I know F, Z, D, and B. Set one, I get the other. Okay, now I know I'm looking for one unknown. And the question becomes, I wonder what that unknown is. And the first thing you decide is there's only a certain set of possibilities. Here, for example, well, we've got to put the feed line on. Here it is. Here, for example, is a possibility. It might be this XD and that XB. Here, for example, is another possibility. It might be that XD and that XB. Here, for example, is another possibility. It might be that XD and that XB. Okay, so I quickly decide I've only got a certain set of possibilities because all these lines are known, I just don't know where they are. So I am going to have to do something like this. I'm going to have to say guess an XB. If I guess here, that's my line, that's my line, that's my equilibrium curve. I step it off. I take the feed where it must be, and I check in. And if n turns out to be right at the corresponding XD, I've guessed right. Otherwise, I make some adjustments. Now, with this fat chalk, I don't know how close we can come to kind of seeing what's going on, but I guess if I fudge it a little, you can see what's going on. Okay, let's suppose you got a, oh lordy, let's suppose you've got a column where maybe you're feeding it on stage 1. Oh boy. Now, you might imagine that in general feeding on stage 1 is kind of stupid. And if I do this calculation feeding on stage 1, the first thing you'll say is, well, you twit, you should have fed it on stage 2, and when you do that calculation, you'll say, boy, you're wasting your time. You probably should have fed this thing on stage 8 or something. Anyway, the feed's here, say. Feed line's there, say. I'm going to guess one of these operating lines by saying guessing XB. So that gives me a point right there. Now, there's an equilibrium curve lying around here, but before I put that on, because I'm going to fudge this, there's a corresponding XD, say, fits in like this. Now, you've guessed this XB, that means you know that XD. You've got to get from there to there in the given number of stages, taking the feed, say, on stage 1. Let's see if we can make that a difficult thing to do. Okay, so here I am. I make an equal, there's my reboiler, and I come up here, and I must take the feed right there. It's on stage 1. So I maybe have 5 more stages, so I go 1, 2, 3, 4, 5. No, I didn't make it. So what have I done? I've guessed that the column's doing too much. It will never knock the XB down to there. And where I lost the game was basically in here because I fed it on stage 1, so I will come and try this again. And now I won't guess so aggressively. Maybe I'll guess here. And I'll try and draw these lines about the same. Now I think with this XB, now I think I'll make that XD. Now my equilibrium curve, well, I've made my life too easy this time. Anyway, this is the reboiler. Oh boy, I'm still tight, but not as bad as before.